Good morning. So many ways to answer this first question. Amy solved the equation 2x squared plus 5x minus 42 equals 0. She stated that the solutions to the equation were 7 over 2 and negative 6. Do you agree with Amy's solutions? Explain why or why not. So they're giving you the solutions and asking if you agree. So many ways. You could solve it on your own to see if you get the same solutions. You could graph it and find the x-intercepts and use that to support your answer. Or we could use plugging in, and that's what I'm going to do. The first solution, 7 over 2, you could plug in. And find, does that equal 0? So I'm going to pull up the calculator. Just put it in as you typed it, as you wrote it out, rather. Outside the parentheses, squared plus 5, parentheses, 7 divided by 2, minus 42 does, I typed it in incorrectly, so that's no good. Get rid of that minus 42 inside the parentheses. It has to go outside the parentheses, and that equals 0, so that checks. However, that's not enough. If that didn't work, it would be enough to say it is not the solutions. However, we now have to plug in the second solution. Negative 6, and for both of the x's, does 2, next input, 2 times negative 6 squared plus 5 times negative 6 minus 42. Does that, yep. So do we agree with Amy's solutions? Yes. Explain when I plugged each solution into the equation for x, it satisfied the equation or made it true. That's it. Number 2. What makes this one different? What haven't we seen? The parentheses. So we still need to get this equation set equal to 0 before we could solve. However, you wouldn't see that yet because being that there's nothing squared, you wouldn't immediately identify it as a quadratic until we get rid of those parentheses by distributing. 2m times m is 2m squared. 2m times 4 is plus 8m equals m minus 3. Then once you see that there is an m squared, that's when you should identify this as a quadratic equation and know that you need to get it set equal to 0. So you should subtract the m from both sides, and now you would have 2m squared plus 7m equals negative 3. Add 3 to both sides. There's no like term. Oh, that's nice. Seriously? Oh, it feels like we're back in school right now with my technical difficulties. 2m squared plus 7m plus 3 equal to 0. So now we have a quadratic equation set equal to 0. I like that I see only plus signs in this trinomial. It makes the factoring easier. However, we have a trinomial, and there's a number in front of the x squared, or in this case, m squared. So how am I going to solve this? I'm going to have to split the middle. So I'm going to actually recopy the entire equation up here so I have room to split the middle. I could do actually the 2 times 3 here. It has to multiply to 6, add to 7. Again, because everything's positive, it makes it easier. 6 times 1 is 6. 6 plus 1 is 7. So that's how I'm going to split the middle. I'm going to bring the 2m squared down. Instead of 7m, I'm going to write it as plus 6m plus 1m, because those numbers give me the correct multiply and add number. Now some of you are still really struggling with the next step. Both of these could be divided by 2m. Most of you write that 2m there. It's then remembering that that's what goes in front of the parentheses before opening them up. 2's cancel, m squared divided by m is m, plus here the m's cancel, 6 divided by 2 is 3. Bring down the plus sign. What goes into both of these? Nothing other than 1. So I'll bring a 1 outside, m plus 3 equal to 0. So my m plus 3 will be my first factor, 2m plus 1 is my second factor, and then I still need to solve. So I'll tee it up, put the line down, set each factor equal to 0. First one has no coefficient, so I just subtract the 3 and get m equals negative 3. Second one, minus 1 from both sides, so 2m equals negative 1. Divide by 2 on both sides, I get m equals negative 1/2. So your solutions are negative 3 and negative 1/2. Those are your two solutions. Okay, next one. Again, doesn't have like an x squared right away, but we have a binomial squared. So when you have a binomial squared, how am I going to proceed? I'm going to make the boxes to actually do y minus 3 times y minus 3. Anytime you're squaring a binomial, it requires you to multiply twice or double distribute. So y squared minus 3y, negative 3 times negative 3, positive 9. And I could simplify. Negative 3y and negative 3y is negative 6y plus 9. So when I have that binomial squared, I have to bring down that trinomial y squared minus 6y plus 9 equals to the 4y minus 12. Now, as soon as I see that squared term, I know it's a quadratic equation, which requires me to get it set equal to 0. So I'm going to minus 4y on both sides, and I could add the 12 on both sides in the same step, because it lines up with your like terms. I get y squared, negative 6y and negative 4y is negative 10y. 9 and 12 is plus 21, equal to 0. Nothing in front of the square term here, so there's a leading coefficient of 1. So this is a basic add multiply. However, everything's not positive, so we're not going to have two positive numbers like before. So numbers that multiply to 21, 1 times 21, 3 times 7. They have to multiply to a positive 21, so I know that they're going to both be positive or both be negative. Since they have to add to a negative, they're both going to be negative. Which pair also adds to negative 10 is the negative 3 and negative 7. So no splitting the middle here because the leading coefficient was 1. I go from that to y minus 3, y minus 7. And again, it has to solve, so I'm going to tee it up and set each of these equal to 0. And my solutions is actually positive 3 and positive 7.